42.
The Radio Wammo Breakfast.
Time to stare into the night sky with Dylan Storey from the Auckland Stardome Observatory. Thanks very much to them. Dylan Storey, good morning to you.
Good morning, Wammo.
And today we're talking about the discovery of possibly an Earth-like planet. Now, I feel like I've heard one of these stories kind of every other week in the last few months. But what's so different about this one?
Well, I did talk about this a few months ago because the Kepler Observatory in Hawaii thought they'd discovered an Earth-like planet and were sort of celebrating this. But they actually went back and had a look at their data and thought that it might not be quite right, so they couldn't actually confirm that. So, in fact, now is the first Earth-like planet that's been discovered. It's actually been quite a remarkable discovery by the Kepler satellite, which is put up there especially for finding planets.
Yeah.
And it hasn't found just one, but 68 Earth-sized planets.
Oh, okay. What? Now, close to each other, or in very different places?
Close to each other, relative to us, because Kepler satellite is its job is just to look at one little area of sky. In fact, it's only looking at 1/400th of the sky, and so its job is to just to stare at that sky, monitor all the stars, and pick up the signs of planets there. And the remarkable thing is that this is only from the first 2 months' worth of data. It's been up there almost 2 years now, but it's actually sending back so much data back to Earth that it takes so long for that information to get processed by scientists and technicians back here that it's only just the first 2 months of data come through now, and it's revealed 1,200 planetary candidates. So that's 1,200 things that look like they could be planets on other stars. They just need to be confirmed. So to be scientific about it, they need to be repeated and then repeated another time to be confirmed.
Yeah.
But they're getting pretty good at knowing what sort of data now is going to be confirmed. You know, what sort of data will produce a confirmed planet. So that's 1,200 possible new planets. 68 of those are Earth-size. 54 of those are in the habitable zone, and 5 are both in the habitable zone and are Earth-size. So that's quite exciting. We've basically gone from 0 to 5 other Earth-like planets out there. So the implications of this are one that the galaxy contains many planets. Countless stars in the galaxy contain planets. So that's very useful to know. And 2, that there are many Earth-like planets out there. That it is possibly very common to have planets in the right size, of the right temperature.
Yeah. How much detail do we actually know about these planets, though?
Because they're just being confirmed at the moment, not that much. But when they can be studied in the future, you can actually work out a fair bit of detail. We can't actually see them. We can just detect them there from the light they block out from their star. But there's quite a bit that, once they've been looking at them for a while, there's quite a bit they can tell from the little blips of light that they block out. For example, if the planet has atmosphere around it, it will slowly change the light, fractionally before the full light block as the atmosphere goes in front of the star. And as the light from the star goes through that atmosphere on the side of the planet, it can have a minuscule color change. So based on that, it could be possible to detect what sort of gases are in the atmosphere.
Really? So whether or not there was enough oxygen to support life?
Exactly, yeah.
Wow.
It could possibly even detect if there were any organic or biological compounds in the atmosphere.
All that from just analysing the light. That's from so far away. That's astounding.
From so far away, and it's only a tiny little fraction of the star's light that's being blocked out. Because you think of a planet, especially an Earth-sized planet, it's going to be so small compared to its star that the amount of light that it's going to block out is really, really tiny. So it's the science of it, the art of it, is just to make really, really precise observations of that light dip, that light blockage.
Really, really astounding. The other thing I wanted to know this week, Dylan, I heard a news story about the possibility that we might get a second sun sometime soon from a supernova that is a collapsing star many light years away.
Yeah, a supernova is an exploding star, actually.
Oh, okay, right.
Stars at the end of their life, when they run out of their nuclear fuel, all these physical processes go on, and eventually all the star's material will suddenly collapse into the center, and that collapse will spark the biggest explosion known.
Yeah.
Which will sort of basically release all the star's energy, all the star's nuclear energy in one burst. And a star can release as much energy as a whole galaxy for a number of hours. So the supernovas, they're absolutely massive. So if something near us goes supernova, we're going to know all about it. You know, it'll be, they're thinking sort of at least as bright as the full moon, probably if one of these stars near us goes, it'll be visible in the daytime.
And when
possibly
you say,
even as bright as the sun.
But when you say goes, possibly it has already happened many millions of years ago, but it would take that, a certain amount of time, light years, whatever, to actually reach us. So it may have already happened. We're just not aware of it yet.
That's right. Yeah. There are a few supernova candidates nearby us. The sort of two most prominent ones, they can easily be seen with the naked eye. One's called Betelgeuse, one's called Antares. Betelgeuse is visible at this time of year if you go outside and look sort of slightly east of north, just after dark. You'll see a bright sort of reddish coloured star. So it's red because it is about to blow up. It's a red supergiant. It's in the constellation Orion. I'm
thinking that if every human was all at one time said Betelgeuse 3 times, we could probably invoke it to happen immediately. Yeah. Anyway.
Yeah. I mean, it would be great from a scientific point of view. It'd be great to study a supernova.
Yeah.
But we're not really sure not completely sure that it wouldn't actually have any harmful effect on Earth if Betelgeuse did blow up, because it's 600 light years away, Betelgeuse. So,
but they're saying though that it could create. There'd be no night, perhaps. There'd be a continuous sort of daylight, and that would really throw things into havoc here on Earth, no doubt.
Yeah, that would, but it would only be for a few hours to a few days.
Oh, okay.
The problem would be more the potential radiation dose that we'd get that could possibly have electromagnetic effects on our atmosphere. The problem with supernovas is you get the full blast of them if you're on the poles of the star. So the star's spinning, and when it blows up, most of the energy comes out the top and bottom as it sort of gets sent up in space and on the axis of the star.
Yeah.
Luckily, we're not lying on the axis of the star of any of the supernova candidates nearby, such as Betelgeuse or Antares, but we could still get quite a decent dose of radiation from radially out of Betelgeuse.
And of course, that's the ultimate destiny of our own star, our own sun.
Sort of. Our sun's not big enough to supernova. It requires a certain mass limit to actually explode. So our sun's not big enough. It's just going to sort of shed its outer layers. It will do some kind of exploding performance, but not a full-on supernova. It'll swell up to a huge size, engulf the Earth, engulf Mars, and then just shed its outer layers, leaving a white dwarf. That won't happen for 5 to 8 billion years, so
that's reassuring.
You don't
right.
need to worry too much. And when they say Betelgeuse is, it's going to explode soon, or Antares, by soon, in astronomy terms, we mean any time between now and the next few tens of millions of years.
Yeah.
So, there's no point in actually waiting for it or worrying about it at this stage.
Okay, so can you go and check out Betelgeuse right now at the Auckland Stardome Observatory?
Yep, it's a good thing to see in the night sky when you go out. You can see it in the planetarium, get a good fix on where it is, and learn about the constellation and everything. Then go outside and have a look through the telescope.
Cool.
Normal stars aren't that great for looking at through telescopes. They just look like points of light. But there's heaps of other cool stuff around there. Near to Betelgeuse, there's the Orion Nebula, which is really cool to look at.
Great, cool. Yeah. Well, go and do that at the Auckland Stardome. Thanks very much, Dylan.
Yes, thanks, Wammo.
Mr. Dylan Storey, you can find him on Twitter as well, twitter.com/Dylan Storey. Time now here